Some problems here. What is the area of triangle ALC in the figure given below? So there are two ways to solve this problem here. We can either solve for the area of the rectangle and then subtract the sum of these two triangles here from the area of the rectangle, or we can solve for or find the length of LC by finding the length of DL first using the Pythagorean theorem, and we can solve for the area of triangle ALC. So now let's do that. It's given here that the length of the rectangle is just equal to 7, so this is side AB, and the width of the rectangle is just equal to 3. This is side AD. And now to solve for the area of triangle ALC, we just have to solve for the area of the rectangle and then minus the sum of the area of triangle 1 and triangle 2. So this is triangle 1 and this one is triangle 2. Now let's solve for the area of the rectangle. So area of the rectangle is just length of the rectangle times the width of the rectangle. So we already have the values here. So that is 7 times 3. So the area of the rectangle is just equal to 21. And now the area of triangle 2. So we're already given the height, which is 3, or just equal to the width of the rectangle. So area of triangle 2 is just 1/2 its base times height. So that is 1/2. The base is 7 times height, which is 3. So area of triangle 2 is just equal to 21/2, or 10.5. So we now have the area of the rectangle and the area of triangle 2. Now let's solve for the area of triangle 1. To solve for the area of triangle 1, we need to find the value of one of the legs or the base of this triangle here, which is DL. And how are we going to do that? We use the Pythagorean theorem. Okay, so let's use the Pythagorean theorem. That is c squared equals a squared plus b squared. C here is the longest side, or the hypotenuse, and A and B are the two legs. So our C here is side AC, which is equal to 5. So that is AC squared equals AD squared plus DL squared, and the value of AC is just equal to 5, and then AD is 3. Now we can solve for the length of DL. For DL is just equal to, so this is 5 squared minus 3 squared equals DL squared. 5 squared is 25. Minus 9 equals DL squared. This is just 16. Okay, and then we square root both sides. Therefore, DL is just equal to 4. So this length here is equal to 4. And now we can solve for the area of triangle 1. So area of triangle 1 is just equal to 1/2 base times height. So 1/2, the base is 4 and the height is 3, so this is just equal to 1/2 times 12, or 12 over 2, which is just equal to 6. So now we have the area of the rectangle, the area of triangles 1 and 2. So we can now solve for the area of triangle ALC, and that would be area of triangle ALC is just area of the rectangle minus the sum of the area of triangle 1 and triangle 2. So you just plug in all the values here. So that is 21 minus 6 plus 10.5. That would be 21 minus 16.5. Therefore, the area of triangle ALC is just equal to 4.5. So the answer here is this one. Now let's try the other method. We would get the same answer. So area of triangle ALC is just equal to 1/2 base times height. So the base here is this one, the length of LC. So that would be 1/2 the length of LC times the height, which is AD. Now we don't know LC, but we've already solved for the length of DL, and that is equal to 4. Since the entire length of the rectangle is AB, and AB is just equal to the sum of the length of DL and the length of LC, and we already given the value for the length of AB and DL. Now we can solve for LC. So LC is just equal to AB minus DL, and AB is just equal to 7 and DL is equal to 4 from what we got using the Pythagorean theorem. Therefore, the length of LC is just equal to 3. So this is 3. And now we can solve for the area of triangle ALC. So that is 1/2 base times height. So this is 3 times 3 is 9, 9 over 2, and this is just equal to 4.5. So we get the same answer. So you can choose either of the two solutions or methods, and which one is quicker and easier for you. The width of a rectangle is 2/3 times its length. If the length is calculated to be 9, what is the value of perimeter for this rectangle? If this is a rectangle here, so this is our length and this is our width, as well as this one. Okay. Now to solve for the perimeter of the rectangle, we can just add up all the sides. That can be perimeter equals length plus width plus width. Or we can use the formula P equals 2 times the length plus 2 times the width. And now it's given here that the width of the rectangle is 2/3 times its length. So let's write that mathematically. So the width is just 2/3 its length. So it's like that, and it's given that the length is 9. Therefore, the width is just equal to 2/3 times 9. So this is just 18 over 3. Therefore, the value of the width is just equal to 6. So now we can solve for the perimeter. So the perimeter is just 9 plus 9 plus 6 plus 6, which is just equal to 30. Or we can use this formula here. So that is P equals 2 times the length, which is 9, plus 2 times the width, which is 6. So this is 18 over 3 times 9 plus 2 times the width, which is 6. So this is just 18 over 3 times 9 plus 2 times the width, which is 6. So this is just 18 over 3 times 9 plus 2 times the width, which is 6. So this is just 18 over 3 times 9 plus 2 times the width, which is 6. So this is just 18 over 3 times 9 plus 2 times the width, which is 6. So this is just 18 over 3 times 9 plus 2 times the width, which is 6. So this is just 18 over 3 times 9 plus 2 times the width, which is 6. So this is just 18 over 3 times 9 plus 2 times the width, which is 6. So this is just 18 over 3 times 9 plus 2 times the width, which is 6. So this is just 18 over 3 times 9 plus 2 times the width, which is 6. So this is just 18 over 3 times 9 plus 2 times the width, which is 6. So this is just 18 over 3 times 9 plus 2 times the plus 12, and it gives us the same answer, which is equal to 30. So the answer here is 30. Alan has more than twice as many chocolates as does Alice, and half as many chocolates as does Nadia. If Alice has a number of chocolates, then in terms of A, how many chocolates do Alan, Alice, and Nadia have? It's given here that Alice has a number of chocolates, and Alan has more than twice as many chocolates as does Alice. So Alan has more than twice, okay, 2 times A, more than twice as many chocolates as does Alice. And then for Nadia, okay, it says here that Alan has half as many chocolates as Nadia. Therefore, Nadia has twice of what Alan has. So that would be 2 times 2A plus 2. So this is 4A plus 4. So this is what Nadia has. The question is, how many chocolates do Alan, Alice, and Nadia have? So we just have to add up everything. So that would be Alice's plus Alan's 2A plus 2 plus Nadia's 4A plus 4. Then we can group like terms, that is A plus 2A plus 4A plus 2 plus 4. So this is just 3 plus 4, that is 7A plus 6. So the answer here is 7A plus 6. A line L is parallel to the y-axis and passes through the point 2, 3. What is its gradient and x-intercept? So what is a gradient? Gradient is our slope, and our x-intercept is the value of x when y is equal to 0. So our slope is just equal to rise over run, or the value of y over x. Okay, if we're going to graph this, this is point 2, 3, and it is given here that the line L is parallel to the y-axis. So therefore the slope of this one, because the slope of the y-axis is infinite, so the slope is also infinite. Slope here is also infinite. Okay. So as the line is defined by x equals 2, here, this one, hence its x-intercept will also be 2, because all of its points will be of the form 2y. So the value of x will always be 2. So therefore our answer here is this one. Slope is infinite, so that is equal to positive infinity, and our x is equal to 2, or 2, 0.